Welcome to methamphetamine. Today we are going to do two different integrals and they are really similar. So, first we are going to do the integral of cosine of Lnx over parentheses 1 plus x squared going from 0 to infinity. And second one is square integral of square root of x times sine of Lnx over parentheses 1 plus x squared going from 0 to infinity. They are really similar. And their results are really nice. So check this out. This function, if this is an indefinite integral, it will be too tough, because Lnx is inside of cosine, right? If we don't have this, it can actually be integrated, cosine of Lnx, but over that, unfortunately, we cannot, right? So we have some tricks whenever we are going to solve this in our indefinite integral, definite integral going from 0 to infinity. It should be definite integral. When it's definite integral, I'm going to use the trick, which is our Euler's formula trick. We know e to the power of ix is equal to cosine x plus I sine x, right? So I'm going to put Lnx inside x, so we can get cosine, figure out what is cosine of Lnx, right? So e to the power of I times Lnx is equal to cosine of Lnx plus I sine of Lnx. So here, this one you can simplify. Bring this side into the x because of the log property, right? So you can cancel the e and ln. So you get x to the I is equal to cosine of Lnx plus I sine of Lnx. So whenever you see a cosine, you are going to take a real part, right? So if this is sine of Lnx, you are going to take the imaginary part. So you can put the RE here, the real part. Wait a minute. Of the integral. Don't mind. Please do not judge me. Judge me if I don't put down the parentheses. Let me just put down my RE and it will be easier to write. So the integral of x power of I, this one is equal to x to the I and then take RE of that. And then this one I'm going to stay the same, which is parentheses 1 plus. Sorry. I need to change the pen. Give me a few seconds. This pen does not have ink anymore. No. So this 1 plus x squared stay the same. 1 plus x parentheses and a square. So here's the deal. X power of something divided by 1 plus x power of something. I'm going to use the beta functions. It's the third one, right? Or we have three forms of the beta functions. Not three form. Or you can call it as three form. One of them is just the integral of x power of m over 1 plus x power of m plus n dx. This is just due to our beta functions. Beta, I like to write it as the beta side because it's called the beta functions. So I'm not going to use the b. But some people might use b, but I would like to use the beta because it's mesh. The beta functions is name. Mesh is name, right? It's not called the b function, right? So this is equal to beta of m comma n. So it should be a negative one, I think. Negative one. X power of m minus 1 divided by that. So here is the deal. I would like to write this I as I plus 1, right? And then minus 1, right? so we can get back the original. So, and then we are going to take this I plus 1 as our m, right? 1 plus x, and then power of our I plus 1. And here's the deal. We have a power is 2 here. How can we do it to get our original? Yes, to get our original, we should have a negative I, right? You know, we must have a negative I. So I and I, they cancel each other. I and negative I, they cancel each other to get a willpower. And then we are going to add 1, right? Plus negative I plus 1, like that. So here is just our m. I plus 1 is just our m. And then this is I plus 1, this is our m plus parentheses. This is just our n, power n, right? You can get by the original square, right? Just 2, power of 2. So we are going to use the beta functions, which is take a RE of a beta of our I plus 1 comma negative I. Let me just follow the order. Let me write this as 1 plus I. Let me just write. I'm a little bit lazy, just write this as 1 plus I, and then write this as 1 minus I. So, you know, beta of something comma something, you can write this as our gamma of 1 plus I times gamma of 1 minus I, and then divided by gamma of that. Right? This one plus this one, m, gamma of m plus n, right? So this one plus this one, I and negative I, they cancel each other out, and the 1 plus 1, which is just 2. So here's the deal. Gamma of 2, if you don't know how to do a gamma of the whole number, just do it really quick. Just minus 1, you get the number 1, and then take a factorial of that. Because our gamma of x, which is just due to our parentheses x minus 1 factorial, you know. So this is a quick trick. 2 minus 1, which is 1, take a factorial of that, which is also 1. So you're going to get divided by 1, it doesn't matter. So here's the deal. Gamma of 1 plus I times gamma of 1 minus I. How can we simplify it though? Here's the deal. Gamma of 1 plus I. So I'm going to use the formula gamma of 1 plus n, right? Or use x. Use x doesn't matter. Gamma of 1 plus x is equal to x times gamma of x. Use this property. And then you are going to get, this is just our x, right? So you get gamma I times gamma of our I, right? Consider our I is just our x. I times gamma of I, and then times gamma of 1 minus I. I'm going to stay the same. Just stay the same right now. Because we are going to use a formula. Should we remove the, is the real part of this? It's just 0 to 0, because we have, is this true? I times something. We don't know what is this number, and then take a real part. If you consider this is a real imaginary number, you get a 0. And that's not true at all. We need to do more work. Because you are not sure is whether it is a real number or imaginary number. So I'm going to keep this I and this RE and do it later. So here's the deal. Gamma of x times gamma of 1 minus x. This is also a really famous formula. This is called the Arrhenius reflection formula, right? Which is gamma of x times gamma of 1 minus x. This is equal to pi divided by psi times pi x, right? So replace this with our pi, right? Divided by psi pi times I, right? Because our x is just an I here. So psi pi of I, you can change this into our identity. Psi of I x is equal to I times sinh x, which sinh is the hyperbolic psi functions, right? It's called sinh, or you can call it as our hyperbolic psi x, hyperbolic psi x. So you get a I times sinh pi here. So this I and I, they cancel each other out. So here's the deal. Take the real part of inside. Pi over sinh pi. You pretty much just get the original, right? Pi over sinh pi. Because pi over sinh pi, which is a real number. Take a real part of that, which is just equal to that. Again. So you can also figure out what is the integral of this. Psi of ln(x) over 1 plus x squared dx. So if this original integral is psi of ln(x) divided by that, we already do this. This one we already do this, which is equal to pi over sinh pi. But psi of that, you are going to take the imaginary part. So imaginary part of this, which is equal to 0, right? Because we don't have an I here. The imaginary part, which is just our 0. So we also do this integral at the same time. So the next question, you know, this is very similar. Psi of ln(x). Last integral, we take a real part, cosine of ln(x). Right? This time we are going to take the imaginary part because of this, right? The imaginary part of our, I'm going to write this x square root of x as x power of 1/2, and then psi of ln(x), which is im of x power of I, and then bring the im outside the integral, right? And then divided by parentheses 1 plus x squared. And then we are going to combine the power 1/2 plus I, right? 1/2 plus I divided by this. So use the beta functions. Once again, we're going to get this number. So do it really quick. Together, we want a -1 here. What should we do? Let me just add 1 and then add 1 and then -1, right? So 1/2 plus 1, which is just equal to our 3/2. 1/2 plus 1 is 3/2 plus I, and then these -1s stay the same. And then x raised to this power, right? Let me just leave some space here. 3/2 plus I -1 divided by parentheses 1 plus 6, and the power of this, right? M. So we are going to add another power. What should we add, right? So 2, we have a 2 here. So we get an I here, we need to minus I, right? So minus I to cancel out the I each other. So you get the real power, right? And then 3/2 plus what will give you 1/2? Will give you 2. So of course this just 1/2. So 3/2 plus 1/2, you get 4/2 divided by 2, which is just 2. I and I, they cancel each other out. I and -I. So you will get the powers 2, right? So we are going to use the beta functions. This is our m -1. And this is m, and this is n. So you will get beta of 3/2 plus I, comma 1/2 minus I. So this is just due to imaginary part of our gamma 3/2 plus I times gamma of 1/2 minus I divided by this. So here's the deal. This one plus this one, I and I, they cancel each other out. I and -I. The 3/2 plus 1/2, which is 4 over 2 and then divided by 2, which is gamma of 2. We get a gamma of 2 once again, which is just our divided by 1. So it doesn't matter. So here's the deal. So should we write this as -1 plus 1? No, because you are going to get -1 over 2 minus I times gamma of -1 over 2 minus I. And you are going to get this number lesser and lesser. So don't do that. So I'm going to write this 3 over 2 as our 1 plus 1/2. But I'm going to bring that 1 to here. And then this one you stay the same. And then divided by gamma of 2. This is just 1. Right. So this one, which is just gamma of 1 plus x, which is gamma of x plus 1, is equal to this one, parentheses 1 plus 1/2 plus I times gamma of 1/2 plus I, right? And then times gamma of 1/2 minus I. So here's the deal. You're going to get the imaginary part of stay the same, 1/2 plus I. So do we have a formula of this? Gamma of 1/2 plus I times gamma of 1/2 minus I. It should be 1/2 plus x, gamma of 1/2 plus x times gamma of 1/2 minus x. Of course, yes, this is really cool. Just use the formula once again, which gamma of x and then times gamma of 1 minus x, right? Let me just it should be our gamma of 1/2 plus I times gamma of 1/2 minus I. We want a 1 here, right? We need a 1 really bad, right? It should be -1. We need a -1 here. So here I'm going to write this as, let me just prove the identity first. So this one, I'm going to write the negative version of that first. So this is just gamma of 1/2 minus I. And then this one, we can write this as our 1 minus something, right? We want 1 minus something to get our pi over psi pi of something. We want to do that. So this is just gamma of something times gamma of 1 minus something, right? That's something. Be sure we need to get back the original. Put them in the parentheses. So 1 minus what will give you 1/2, which is just 1/2. And then minus what will give you x back. So minus x. So overall, you are going to get pi over psi times pi psi of pi times 1/2 minus x. So we are going to distribute the pi inside. You get pi over psi of pi over 2 minus pi x. So what is this? Psi of pi over 2 minus something, which is just cosine, but pi over cosine of something, which is really cool. Pi over cosine of pi x. So this one just match it, right? This one just equal to our pi over our cosine of pi I. So here is the deal. So cosine of pi x, which is a cosine of ix. This time we don't have an I, which is just quash x. So far you get this is just quash x. And then we are going to distribute this inside, which is just pi over 2 times quash x plus I pi over quash x. And then we are going to take an imaginary part of this, obviously, which is just equal to pi over quash it should be quash pi. Pi over quash pi. Or you can write this result as pi over it should be pi. This solution you can write this as pi times cosecant x. Stop writing x right now. Pi times cosecant x, and this one you can write this as pi times secant pi. Right. So that's it. Of course, you can also do this integral, square root of x times cosine of ln x divided by this. Just take the real part of this time, which is just equal to pi over 2, and bring this to the numerator. You get secant. Stop writing x. Why I keep writing the x here? I don't know. Pi over 2 times secant pi. We get two different results here. That's really, really nice. You know, I think this video is not enough, so I need to stop it right here.